All right. Hope everybody's having a great day. Couple of reminders. The big one, of course, I've been telling you about since last week. What is happening tomorrow? That is your exam. Okay, so we're looking at having piecewise functions on there. It's going to have languages of functions, graphs of functions, everything we've been talking about since last Monday. So if you have any questions, there's one final review period tomorrow morning, 7:45, if you want to come on in. As far as piecewise functions, you have an assignment, but it's not going to be due. Okay, if you go ahead and take a look at the website, they were there, piecewise functions, homework key. So as you're looking through that, if you want to go ahead and check yourself, if you're making mistakes, definitely come on in. Let me help you with that. But also right below that, I've got a couple of quizzes that I would have given you had I had time. But not only are the quizzes there, but the answers are also there as well. So really good additional resources here if you're looking for some extra practice on those. All right, so that test is coming up tomorrow. You'll have the entire period. Of course, we'll go ahead and finish it in that time. Friday, my plan is to go ahead, talk about any difficulties or problems you had on the exam, hopefully kind of fill in any gaps or holes or misunderstandings that there might be. I'm thinking about also possibly even moving on with the next focus activity. Now, this first set is only going to have how many? 4. This is the last focus activity in this first set, but we're going to try to have at least 2 sets per 6 weeks. Okay, so if I don't start it on Friday, the next time you get a focus activity, it will be number 5. Okay, and then however far we're able to get, I'll have you turn those in at some point. Okay. But the focus activities, these first 4 are going to be due on Friday. A lot of people are turning them in today just to be done with it. That is perfectly fine. If you want to wait till Friday, perfectly fine as well. I think that's all I have. Oh, the drills. Okay, what are the drills happening today? Okay, you got to lock out during what period? That's 4th. Okay, so the building's locked down. I mean, the doors are going to be locked like they normally are. So besides them probably making an announcement, I would imagine your teacher's saying something, business as usual, so that one's really not going to affect the flow. But what will? The lockdown during 7th period. Okay, that's where hopefully your teachers have been talking to you about what to do in case there's some kind of threat on campus. Let's say one happens in here. What do we do? There you go. So right over here between Lane and Fernanda, right in this area, we get over by the wall. I'm going to have to ask you, don't worry about personal space, because in the long run, it's probably better to be uncomfortable for a short while than, unfortunately, to have some kind of harm or death come upon you. We don't want that. Definitely away from the doors. I'm closing the windows. We won't be making any noise. Please don't get on your cell phones when this occurs. Your teacher should be telling you at some point, probably a little bit after it's begun. Send a short message to your folks. I'm okay. I'm in this room. More to come later. Something very similar to that. All right. Well, I think that's all I got, unless anybody has any questions. All right, let's do it. Well, the 2 main objectives we have today are to finish up the focus activities and to finish the lesson on piecewise functions. And then what we do after that, whatever you believe is going to be the most beneficial, we could talk about questions on the homework. After I pass back the papers, we can go ahead and look at the quiz. And speaking of, your class average was 92.2 on yesterday's quiz. So excellent job, excellent job. Okay, you came in 2nd. First period beat you out this time. Okay. But that's okay. That's okay. That just means, next time we'll take care of them. Like on that test tomorrow, we'll have the highest average. All right. So we can talk about that. Or if you just want to take the time to go ahead and study, we should have, I think, 2nd period ended up with about 11 minutes or so left in class. Not a lot, but, it's not going to happen often. Okay. All right. Well, let's go ahead and take a look at this right here. Okay. Number 1. All I want is set B. So let's go ahead and get some volunteers up here to help me with this. Who could show me the set of all the elements that belong to set B? Okay, Natalia is going to start it for us. And then as we go through, I'm going to have you guys explain to me what these symbols mean, because I don't remember. Okay. So she says E, F, H, I, and J. That's perfect. Oh, didn't like that bracket? There we go. All right, I think that's perfect. Okay, every element that belongs to set B. That's exactly right. Okay, well, what does that little tick mark mean on number 2? That's the complement. Okay, so some people have been describing that. What is that again? Okay, so presumpsa, one more time.
Like everything that's not in A.
Everything that's not in A, okay. So would you like to come on up and show me? All right. Oh, that's fine. That's fine. I'm not grading this per se. Well, that's okay. You grab the red pen. That's fine. So how many elements should belong to this set? I heard 6. I heard 7. 7. Okay. There we go. So the complement of A, or the complement of any set, is every element still in the universe, but not in that particular set. Perfect. Okay, well, what does that upside down U mean on number 3? That's the intersection. Andrew, what does that mean?
What they have in common.
What they have in common. Okay. Would you like to show me this one? Okay, perfect.
Well, that's good enough.
Okay, that's fine, yeah. There you go. The only 2 elements that belong to both A and B, remember that's the key word, and with an intersection, is going to be E and H. All right, perfect. Number 4. Okay, so what's the U mean? That's the union. Okay, so that's the marriage. Okay, that's a complete combination of both sets. And then we just talked about the complement. So I want the complement of the union. Who believes they can help me out with this one? Okay, William, thank you. Does anybody think they know how many elements should belong to that set? 4. Very good. Okay, nice.
Everything in both of these is the union, so everything else in the universe is the complement.
Okay.
Okay, that'll get.
There we go. A lot of people today are not impressed with their little brackets. I think they look great. So he says ACGK. Perfect. Okay. If you did want to go ahead, shade, kind of manipulate the universe here, remember, he said the union is everything that belongs to both A or B. So we're going to be combining the 2 into one brand new set. So that's the union, but I want the complement. So everything not belonging to the union. Perfect, perfect, perfect. Now, I'd already gone to the copy machine when I did this, but I think this actually appeared on your quiz, right? Was it negative 2/3? Okay. Then what I'll go ahead and do is just talk about the hierarchy again. We now describe every value as what? Complex. So everything is complex. Okay. And let's see, who can I go to? Okay. What 2 subgroups are there that make up the complex numbers? Real and imaginary. There we go. So we have the real. We have the imaginary. Okay. Now, if it's imaginary, there are no further subgroups. But the reals, okay, Adrian, what does that break into? Rational and irrational. Okay. How do we define the, or I shouldn't say define, what letter is used to describe the rational? Q. Now, remember, because we're using I for imaginary, we're starting to use R minus Q for irrational. Or you could say R\Q. That's perfectly fine. Now, if something's labeled irrational, you can't go any further. What's the next subgroup of the rationals? The integers. Then we have the whole numbers, and then finally the natural numbers. Okay, good, good, good. Just going to throw this out there because from time to time I may go ahead and have some kind of in-class assignment or problem geared a little more towards my IB students. Who are my IB students in here? Okay, because you are going to be responsible for certain material as you move forward as well, not necessarily just what we do in here, but since we're talking about the hierarchy, IB sometimes does things a little differently. Okay, like in IB, They don't have the group of whole numbers. In fact, what's the only difference between the wholes and the naturals? Yeah, 0, right? So in IB, the natural numbers is the set from 0 and your positive counting numbers. But they don't even always call it the natural numbers. In IB, they could very well refer to those as the cardinal values. Okay. Now, just to let you know, in here, we are definitely going to have the set of whole numbers. But again, if you're an IB student, that could be something that could potentially come up at some point. Okay, good. Good. All right, now that, as I said, is the last one in this first set. So at the end of class, not right now, we'll have time, if anybody wishes, you can staple those 4 together, turn them in. As long as you have them and they're worked, that should be guaranteed 100 for you. Okay. All right, well, let's finish up with piecewise functions. Okay, so I believe we only have the one problem left, and then we're done. All right, so what's the problem say? Number 7. Okay, and sir, since you're brand new, any extra copies I have will be over here. So let's see. I started the. Okay, here's the notes. Okay, all right. Okay, so it says, in August, Orlando Utilities Commission supplied electricity to residents for a monthly customer charge of $8 plus 10.143 cents per kilowatt hour for the first 1,000 kilowatt hours used in the month, and 12.143 cents per kilowatt hour for all electricity over 1,000 in the month. So part A says, okay, what's the charge for using 920 kilowatt hours in a month? Okay, so parts A and B are kind of progressive. They're set to kind of get you the idea on how to find a particular value to evaluate it. And that's going to lead into part C, where we're actually going to write a piecewise function involving X for any number of kilowatt hours. So what's the charge for 920 kilowatt hours? How would I figure that out? Like, what would I do? Okay. All right, well, let's start with what we know. Is there any kind of fee, even if they don't use any kilowatt hours at all? Or do they have to pay something? How much is that? $8. So no matter what, just to belong to the Orlando Utilities Commission, you got to pay $8 flat fee per month. Plus, okay, now, what am I going to do with the 920 hours they used?
Well, you're gonna.
Fernanda? Uh-huh. Okay, so what value will I use since 920 is less than 1,000? Oh, not the 12 point. We're going to use the 10 point for the first 1,000 hours. Okay, so I'm going to go ahead and take 920, and here's what I'm going to do, and we might have to talk about this for a moment. I'm going to multiply this by 0.10143. Why did I move the decimal? That's exactly right. Andrew says because of the way it was given to us. It was given to me in cents. So really, that's saying you're paying a little over 10 pennies per kilowatt hour. Okay, so you can absolutely go ahead and multiply the 920 times 10.143. You just have to realize that your answer is going to be in number of pennies. But typically when we're talking about, totals, currency, charging, we're going to go ahead and make that in terms of dollars. Okay, which is why I went ahead and moved that over. Okay, does that make sense? Because we're talking about pennies. Cents. I see. I'm funny even when you don't know it. Okay. All right. So even if you don't, maybe before you leave today, I can change your mind. Change. Okay, well, let's keep going. So if I go ahead and do this, I believe I've already got it pulled up here. Yeah, 8 plus 920 times 0.10143, and, we go ahead and round to 2 decimal places when we're talking about currency. So I'd say $101.32. Okay. Whoop. Okay. So $101.32. And again, if you didn't move the decimal, your answer is still going to be correct. But basically, you'd be saying, okay, you owe 10,132 pennies. Okay, but the way we deal with currency, nobody does that. Okay. Does that make sense? Is everybody okay with how I did that? Okay. All right, now what I want you to do, kind of build on that. Figure out B, what's the charge for 1,500 kilowatt hours? Okay, so now you're actually going to have to use both rates, okay? But then seeing what you did in A and B, for part C, I want you to come up with a piecewise function that's going to describe this situation. But in terms of X, any number of kilowatt hours that you go ahead and plug in. All right, so on part C, you're going to have to simplify your expression. Remember, we always want to simplify if possible. Now, while you guys are doing that, I will pass back your quizzes and your papers. Okay. Starting with Cadence, who is not here. Okay. Jaden. Or Galen, I'm sorry. Jaden's in the previous class period, I'm sorry. My fault. Laura. Here we go. Okay, Jake. Okay. Sandra. Clarissa. Sandra. Okay. Philip. Kasha. Josh. Tori. Fernanda. Adrian is here. Oh. Michael. Kate. We have Vanessa. Xavier. Chrysanthemum. Joy. Elaine. Caleb. Okay, then we have Connor. Natalia. Andrew. Then we got Vanessa. We got Laura. Laura. Next one's not Laura. Okay. Will. Caleb. Slender. There's Sandra. Andrew. Dickinson. Okay, Philip. Adrian. Joy. Okay. In the next couple of days, I'll be putting together the website for next week, all that information. But this quiz right here, if you are wanting to retake it, if you made a 79 or below, remember you can get up to an 80 now. I'm going to go ahead and make the deadline by next Friday morning. So I'm going to give you a little longer than normal because next Monday we don't come to school. We got a 3-day weekend. And tomorrow's test as well, I'm just going to keep it next Friday morning. Okay. All right. Okay. So has everybody had time to go ahead and look at B and C? Anybody think they got the answer to B? How much money will be paid for 1,500? Will, what do you think?
$170.
That's what I got. 170, 15. Okay. Now let's talk about how we got that. Okay, kind of think about what we were doing. We're going to continue past what we did in A. You're still going to pay the $8 flat fee. Plus, well, for the first 1,000 hours, that has a specific rate. It's the 0.10143, right? Plus, okay. Now we want 1,500, so how many hours went over 1,000? 500 at the increased rate. What was it, 0.12143? Okay, so a little over 12 cents per kilowatt hour over 1,000. Okay, so once you go ahead and simplify that, That's where we end up with the $170.15. How many people got that right? Okay, good. Anybody have any questions? All right. Now let's talk about C. If C is the monthly charge for X kilowatt hours, okay, so it has to be in terms of X. Write a piecewise defined function for C in terms of X. Well, how many rows do you think you're going to have on your piecewise function? Okay, there's only going to be two. A lot of people are raising two fingers. Well, you've only got basically two parts. Either you're going to have 1,000 or less hours, or you're going to have over 1,000. Okay. Now the first part is really easy. Okay. We go ahead. I don't want to show the entire thing just yet. But we're going to go ahead and have 8 plus, there's the flat rate, plus 0.10143x if x is 1,000 or less. Okay. All right, so how many people got that first part correct? Okay, good. Does anybody want to share what they got for the second part? Anything above 1,000? Once you simplify, you should end up with a binomial expression, just two terms. Okay, let me rephrase the question. How many people have an answer, but they're just not 100% confident that they're correct? There we go. Now I'm seeing some hands go up. Okay, so why don't I go ahead and show you what I got. 0.12143x minus 12 is what you should be getting for that second function. Okay, and I'm already seeing some confused looks on a few faces up there, so we'll talk about how we got that. Okay, and of course, you know, the one thing I'm going to go ahead and point out, there's going to be a finite number of hours in a month. So here, you know, we're just describing going to infinity, but will there be an upper value? Will there be a cap at some point? Yeah, it's not going to go to infinity. You're not going to have 1 billion kilowatt hours in a month. That doesn't make sense. So obviously, you know, understanding that, we just don't have enough information right now to worry about that. So is everybody okay? Was anybody even thinking about that? I'm sure it was probably a very high, you know, on your list. Okay. That's actually pretty shocking. It's an electricity problem. Okay, well, why don't we get back to our current problem then? Our current problem then. Oh, I feel like I'm having to work twice as hard in here. Okay. So did anybody get that binomial expression? Now, let's see if you got close and maybe you didn't realize it. Think about what A and B were having you do. They had you look A and A first at finding the value of a number of hours less than 1,000. Then for B, you found the number of hours greater than 1,000. So let's go ahead and set it up this time the same way. So let's say 8, that's the flat fee you're going to pay no matter what, plus for the first 1,000 hours, you're going to pay, what was it, 0.10143? Okay, cents. Okay, so what's going to happen to that decimal if I just multiply it by 1,000? Yeah, it's just going to move the decimal 3 over. So this is really $101.43. Okay, so if you go to exactly 1,000 hours each month, you're paying $109.43. Would everybody agree with that? So it's only anything beyond that that's going to make it change. So I'm going to go ahead and take plus the amount for over 1,000, 0.12143, but I have to make sure it's only for the number of hours over 1,000. Okay, because think about what we did a moment ago. Let's apply 1,500 to it. Okay, think about what we did with the 1,500. Well, you'll notice I've already accounted for 1,000 hours here. But if I do say that X is 1,500, if I go ahead and plug that in, 1,500 minus 1,000, see, there's the additional 500 that only gets applied to that rate. Is everybody okay with how I'm doing this? Okay. Well, now that we have that expression, what do we want to do? We just want to simplify as much as we can. Okay. I already said that these two together, that would be $109.43 plus, well, now let's distribute. This would be 0.12143x minus Again, the thousand's just going to move the decimal over, $121.43. And what did I do from here? Yeah, there you go. Just combined your values. The 109.43 minus the 121.43, that's where I got the minus 12. Okay, so this takes care of the fact, really, think about what does the 12 represent? 12 what? Because we know X is the number of kilowatt hours, no matter what it is. From the lower pay to the current rate, that's representing $12 difference. Because ultimately this expression is going to give you the amount of money owed, right? Okay. So did anybody get the expression but just didn't simplify it? Okay, good. So I knew there had to be some folks out there. Okay. All right. Any questions on that? Yes.
I had one. Why did you do parentheses on the 1,000? Because if it's 1,000, it works.
Yes, because according to the way this problem was stated, up to the first 1,000 hours, even if it goes to 1,000, you're still applying this rate. So only if it goes over 1,000. So that's why this one was slightly different from the one we did yesterday.
Even if it mathematically works, you still label it as 1,000. So I mean,
Yeah.
you get the same thing.
Yeah.
Plug it into either one. Okay.
Okay. Any other questions? Okay, so I am now showing 10:33. We have just under 20 minutes left. Were there any questions on the quiz? The quiz from yesterday. Yes, sir.
Could you do number 8?
Number 8.
That was on the homework. Never mind.
Oh, so we can do that.
Yeah.
I mean, whatever you guys feel is going to be the most beneficial. Oh, my baby. Oh, was it yours? Oh, shoot. I mean, I'm still worried about your calculator, but, not as much. Sounds horrible the way I said that. Okay. So now I'll say your baby. There you go. Okay. All right. So, I'm sorry, Will, what were we talking about?
I had asked for number 8 on the homework.
Number 8 on the homework. Okay, so, okay. Before we got to the homework, did anybody want to talk about the quiz? I felt pretty okay. All right. If you do change your mind, I am here in the morning. Okay, so let me make sure that's moved back for 5th period. Okay, number 8. Okay, so let's see what we got here. It says write a piecewise defined function for each function shown below. Okay, so it looks to me like we have a semicircle and then 2 linear functions that we're going to go ahead and just describe in a particular interval along the x-axis. Okay, so again, we're going to start with the furthest left, this one right here. Okay, so does anybody remember the general form of a circle? Okay, what's that? It does involve h and k if it's not centered at the origin. Okay, so a general form of the circle is going to look like this. It's x minus h squared plus y minus k squared is equal to, can anybody tell me? R squared. What does R stand for? The radius. Okay, there we go. So in this case, we know that it's not centered at the origin. In fact, I would go ahead and say the center of this guy is going to be right here. And is everybody okay why I'm describing this as a semicircle and not, say, a semi-ellipse? Does anybody need me to elaborate on that? Okay. So you could go ahead and do a couple of things. This circle has been translated. Imagine he started at the origin. So we just have x squared plus y squared is equal to, well, what's the radius? 3, so I'm going to set this equal to 9. I'd go ahead and say that's squared. So let's imagine that this circle was originally at this right here, but now I want to go ahead and translate this guy. Looks like 3 left. So can anybody tell me what am I going to do? How would I show that I'm going to translate this graph 3 units left? Remember, what's the rule when you're adding or subtracting to x in a transformation? You take the opposite. So before I go ahead and square it, I need this guy to go ahead and shift over.
Yeah, when you're cycling.
I believe I do, yes. There you go, sir. Thank you. Okay, so if I'm going to go 3 left, would that be x plus or x minus? Okay, x plus. Because remember, you take the opposite. Had we been shifted right, then it would have shifted me, would have been minus at that point. Okay, but is everybody seeing why I'm doing this? Think about this right here. This would be my h, this would be my k. Okay, so this guy's going to be at negative 3, 0. Is everybody okay with that? Oh, yes, sir. Oh, I was just seeing if you're paying attention. I was thinking about the radius. I'm sorry. When it looks like I made a mistake, that was just a clever teaching strategy to see if I can catch anybody and if they're paying attention. And obviously, Michael, can't get anything past you. Very good. Very good. Okay. All right, so it is x plus 2. Now, when we're going to go ahead and write my function, okay, remember, we're going to go ahead and say something like f of x equals. So I want this to be solved for y. Okay, so let's take this guy right here, x plus 2 squared plus y squared equals 9, and let's just do that. What would I move first? I'd go ahead and move that quantity x plus 2 squared. You can move a quantity just like you would move a single variable or a numerical value. I'd go ahead and subtract x minus 2 squared, okay, minus x minus 2 squared. Okay, those cancel. Y squared is equal to 9 minus x minus 2 squared. And now what? Now we take the square root because we want to get rid of the square, right? Now, normally at this point, what would I do? I'd go ahead and put positive or negative because algebraically we were taking an even root. But looking at the graph, I mean, we only have the top portion, so the negative is not necessary. Okay? So we have 9 minus x minus 2 squared. So this would give me the function describing that semicircle. In fact, has anybody ever seen, maybe you did this this is one of the things I use when I taught transformations in Algebra 2. I use semicircles a lot. So if I were to give you the square root of, let's say, 25 minus x squared, okay, that's the form of a semicircle, the positive one. Okay, what radius would it have? 5. Okay, so you can go ahead and plug in any value. Now, these are all centered at the origin. This one here, we had to change that. So is everybody okay with that? Did anybody actually get the function itself? No? Did anybody try? Okay. Philip, how close you get?
Not very close.
Not very close? Okay. That would be the toughest one on that problem, I would definitely say. So let me go ahead and erase all this. So for my function f of x, we're going to have, what would I have there? Square root, it was 9 minus x minus 2 squared. Okay. Now, where does he live? What would be his subdomain? From negative 5 to, there we go, let me go ahead and move this guy down a little bit. So from negative 5 to 1, closed circle means I include, open circle means I do not. Okay. And then the other two are just going to turn out to be linear functions. Okay. So let's see what we got here. What's the slope of this guy right here? Just negative 1. Again, you can take 2 points off that graph and use the slope formula, or you can just visually take 2 points, rise and run. So you're going to go down 1, 1 to the right. This one's easy enough. It's right there to connect it. What would the y-intercept be? Negative 1. So on that one, this is probably one of those rare occasions where I would say there's no need to go ahead and use any algebra. What would my function be with a slope of negative 1 and a y-intercept of negative 1? Negative x minus 1. Now, where does he exist? He exists from bracket 1, okay, the 1's included this time, all the way to 4, which is not. Okay. Now, the other one's also pretty easy to figure out. He's what type of line? He's horizontal. Where would he cross? 2, so that one's just f of x equals 2. But where does he exist? What's his subdomain? Bracket 4 to infinity.
Is there any particular order it has to be in?
No, I mean, even if you were to shuffle them up, the information is still going to be the same. Preferably, though, we do like to go ahead and write the functions in order of their subdomains. You see how ultimately we went from the smallest to the largest? We do prefer to do that. Okay. I mean, technically, if you jumble them up, it's not wrong, but caution.
For the semicircle, why did it be x plus 2 in the square root?
Oh, you're right. You're right, because it went left. Yeah, the opposite. Sorry. Okay. All right. So, Will, you asked about that one.
Yes.
Does that make sense?
Yeah, it makes sense.
Okay. Good. Okay. And it's always good to, kind of remember the topics from geometry because eventually everything comes full circle. Philip, what's up? Number 9. All right. Let's do number 9. So it says an SUV was purchased for $35,750. The value of the vehicle decreases by $2,800 per year for the first 4 years and $1,700 per year for the next 6 years. Write a function that describes the value V of the SUV after X years, where X is going to be between 0 and 10. And that makes sense that we're going to cap it here because we have a description for the first 4 and then the following 6. Okay, so I want to know the value of the vehicle after 3 years. Okay, so what am I going to do here? Okay, so Natalia, you said start with what? Okay, so the 35,750. What would you like me to do with that? Okay, what am I subtracting from that? Okay, now we're going to subtract 2,800 per year, and how many years are we looking at? 3. Okay, those are anything else I need to do to finish out? Did I just totally skip A? God, I'm on the ball today, aren't I? All right, let's just go ahead and finish up B, and then I'm going to gracefully step aside and let smarter people get up here. All right, but is everybody okay when I'm done here? Okay, maybe this will help, just like we did on the homework, because I believe A is wanting us to write the function, using X, so we're going to end up with the same thing. We can plug it in. So let's see here. What should we be getting for B? Because I worked this out as well. If today is any indication, we know I'm absolutely correct. Okay. So what are we getting for 3 years down the road? 27,350. Is that what you guys are getting? Okay, perfect. 27,350. Okay. Now let's go back to A. Let's go ahead and create a function now that we kind of have an idea how to do that. So we've only got 2 intervals here, prior to 4 years and after 4 years, the 6 following. So there's only going to be 2 lines here in my function. So let's go ahead and say, I think I called this C of X, or V of X, whatever matter. Value cost. Okay. Who wants to come on up and help me with this first part right here? I'll even go ahead and plug in the subdomains. So this is if X, I'll go ahead and use inequality here. Core and then X greater than 4. Okay. So for this first function, we just need to know if the value of years is anywhere between 0 and 4. Because if it's more than 4, then we have to take off a larger value. Philip, you want to try it?
Oh, well, I'm going to say that at the bottom it's supposed to be 4 is less than X is less than 10. Because A it says at the very end, 3 zeros is less than X.
Okay, technically, let me go ahead and write that out. 4 is less than X, less than or equal to 10. Okay. We feel better? Okay, there we go. All right, so Philip, why don't you come on up here and show me? All right, so I need this first function right here, and then Kaushal, I think I'm going to have you come up and do the second one. a little too big. That's okay. So you're not saying 35,750. You're saying 35,750. Wow, nothing really. Good Lord, this is a tough class. 35,000. We have fun. 750. 2,800. There we go. That's exactly right. That's what we did on B. Very good. Okay, so Kashal. I'm looking for that simplified expression that's going to help me find the value for a number of years after 4, but less than or equal to 10. It's not very simplified? Well, that's okay. We can simplify it. Okay. That's interesting the way you wrote that. Okay. All right. Now, let's go ahead and simplify it. Now, first off, is everybody okay with what he came up with? He's absolutely correct. Does anybody want me to elaborate? Okay, let me elaborate. Okay, so Kashal, if you'll just stand over there by the bookshelf. Okay. Now, we're going to start with the 35,750, right? 35,750. Now, I'm not going to write it as the difference of this big binomial expression like he did. I'm just going to go ahead and look at it as the individual parts. So what happens within the first 4 years? Yeah, it's decreasing in value by how much? 2,800. So I'm going to go ahead and minus 2,800 times 4. Okay. Now, what I'm going to go ahead and do after that is I took minus 1,700, and I went ahead and multiplied that by x minus 4, which is exactly what he did here. See, he just combined both of those into a big parentheses and subtracted the whole thing, right? Because if I subtract it, that plus becomes a negative, right? Okay. Now, see, think about what we did on the kilowatt hours problem. If it does happen to go beyond 4, see, we're still accounting for that difference with the 1,700 for however many it goes over. Is everybody okay with that? Okay. Well, now we just got to simplify it. And your friends can help you out. So, for example, what is 2,800 times 4? Here you go, sir. Coming at you. Good catch. 11,200. Thank you, Natalia. Okay, so we're going to, let's go ahead and distribute. There we go. So 1,700x plus, now we need 1,700 times 4. 6,800, yes. Oh. Are you accidentally putting your hand on it when you do it, or is it just a pen? Here, let me try this. Right now. There we go. 6,800. And then, what are we doing? Minus, okay, then we have the 35,750. Okay. So now what we're looking for, 35,750 minus 11,200 plus 6,800. 31,350. Minus 1,700x. That'll be the expression for any number of years over 4. Fantastic. Okay, Philip. Does that make sense? Okay. Now, given those two intervals, if I want to find the value after 8 years, I'm going to plug 8 directly into this guy right here. Okay. And I ended up getting 17,750. Is that what other folks are getting? Okay. Now, very quickly, let's get those calculators up there. Wow, we ran up to the bell. That's good.